All right. Great. Great to have you, James. I'm here with James Luan, Director of Engineering at Zilliz. And let me just jump right in with a big picture AI question. I think people all over the world are really either going between different emotions. Some people are very scared. Some people are very excited. Um, which camp are you in? Do you think AI is the end of humanity? Is it the start of a revolution in sort of human well-being, or where do you fall in the spectrum in between?
Okay, so I myself is actually very excited. To me, I think the advancement of AI is like more like the next industrial revolution. So it's just like steam, just like electricities. AI will be become fundamental compatibilities for the next 10 years. This means that burning in this area, we have like a lot of power to change the world, right? But it's not like I think it's not the end of the humanity, and it's not the merely the help. I think it's just a powerful tool, help us. Like it has a lot of like risk, but it also have a lot of benefits, right? So the actual powerful AI lies in its acceleration, because AI technologies continues to evolve, right? We've seen that ourselves get closer and closer to AGI. However, I think uh, at least for today, it's not. It's clear that the large language models are still not AGIs. So which means we don't really need to like overly worry about AI controlling the human's world. I mean, we our focus should be like still be how to use AI to solve problems, help to us to improve the efficiency. Yeah.
Great. So, in terms of emotions, are you excited right now? Are you dubious? Are you a bit of both? What kind of emotions do you feel these days? With the progress being made on AI.
So yeah, I've been working for database industry for last 10 years. So the industry is actually move very slow. So I think next big last big thing for database industry is still like when we go back to the cloud. A lot of databases move to the cloud, right? So actually I was very excited about the AGI. I thought it actually brings us a lot of opportunities, right? After mobile applications, I thought AI native applications will be like the next big thing for the whole industry. So yeah, I was very excited.
Very excited, right? Cool. So you've got a long, tenure track in database technologies, right? You've worked on some fundamental technologies and some big cloud architectures. Um, Explain, vector databases to someone who has no idea what they are.
So vector database is actually a purpose-built database for processing vectors, right? So how do we get vectors? Usually, we use something called embedding models, which can help us to convert different kind of unstructured data into a float array, or we just call it as embeddings. So with these embeddings or with these vectors, vector database can help us to find similar vectors or in a high dimensional space, or on the other side it helps us to find very similar unstructured data. So with vector databases you can find similar images, you can find similar query and documents. You can also find similar voice. So basically vector databases help you to accelerate and get insight from your unstructured data with the help of course the large language models and the other like embedding models.
So what got you into studying applications for vector databases? Can you give me a little bit of inside track on when you first encountered this problem or this solution, and what got you into you know working in this field?
Okay. So I think that's back to 4 years ago. Although like vector database is actually a new concept for lot of the audience, but yeah, back to 4 years ago, we already like working on vector databases. And the trigger is that at the very beginning, we are trying to build GPU accelerated databases, but we soon find that the GPU has like too many computation powers, and it's like too expensive for databases for structured data. So we sit down and think about what we can do with the current technology we have. Right, we have a lot of background on databases. We also heavily use GPU to accelerate our data processing. Then we should find something with more computation requirement, right? So we go through all of our users. One of the users, they want to do reverse image search, but they don't find none of the current databases can support processing very large dimensional vector embeddings. So we thought, okay, that's a possibility we have, right? We want to build a database, right? It still access data um, as traditional databases, right? You can use SQL language. You have executor help you to retrieve all the information. You have persistency. You can scale, right? That is still a databases, right? But the data we process is very different from traditional like databases. We try to process high dimensional vector data, and yeah, and since the challenge soon becomes how we can compute it much faster, that's why like GPU jumping that we can fully utilize its computation power. Yeah, that's why we started our journey on the building this vector database.
Got it. Okay, interesting. So I mean, when most people in tech look back, people who've been around for 20, 30 years, it seems to me, I don't know if this is correct, but it seems to me that when I was studying computer science 20 years ago, the only thing we had were SQL databases. Um, I don't know if that's actually correct, or I just was unaware of the other existing database types. And then it seems like over the last maybe 15 years, we've had sort of an explosion in database technology with NoSQL, with graph databases, and it seems like this embeddings databases is sort of the next frontier. So what are the some of the technical sort of difficulties working with vector databases? Can you give some people in technology some hints as to what's coming, or what are the current problems with vector databases or difficulties with dealing with them?
Yeah, I think one of the biggest challenge, or one of the like the big difference between vector databases and all of the traditional databases is semantic and uncertainty. It's kind of like large language models, right? You gave in some queries, or you gave in some prompts, right? They give you different results, and uh, for vector databases is also similar. We cannot achieve 100% accurate. It's more like you just need to find reasonable result, and how to evaluate reasonable is going to be like a big challenge for all the vector database providers. And of
Got it.
course, since vector database is we handle all these high dimensional data, right? So uh, for most of the traditional databases, they just handle strings or integers, and those data can be just compared between each other, right? But for high dimensional data, is very hard to compare, right? For two dimensional data, you just cannot compare which one is larger. Is it San Francisco or if it's LA, right? Because you have two different dimensions. If it's
Mhm.
become higher dimensional data, right? Then it becomes more difficult to compare. What you can do is you can find similar data, and that makes also vector database very unique. Is that you cannot use traditional index technologies. For traditional databases, they use B trees. They use all kind of like sorted data structures, helps them to accelerate. Right, when you build index, you also like try to like order all the data based on your like index case or your primary case, right? But for vector DBs, you have to use very different data structures. We use uh, graphs, we use trees, which help us to accelerate on our high dimensional data. That also like make vector DB very different.
Got it. Got it. Yeah. So maybe more, richer content types and data types, but also then higher uncertainty in results. Right. Seems like there's a trade off there.
Oh yeah, so yeah, and yeah, I just want to like comment there. Exactly, I think the uncertainty is also related to semantic, right? If it, I think vector based is more like the future because it's more like what our humans try to react on, because we also have like different kind of react, right? We for different people, right? We have different behaviors on the same actions on the same message. For vector based is also kind of like similar, right? And I think
Right.
that is what the uh, why we think larger models can be worked together with vector DBs just because they understand semantics.
Yeah, in a way, I mean, you're kind of making me think now. In a way, again, I don't think we're anywhere close to AGI, as you mentioned earlier, but I think, in a way, that the systems that we build seem to be behaving in a more human fashion. If you think of a traditional SQL query, is very deterministic. You're going to run the same query, you're going to get the same data again. And as you mentioned here, with these new tools, you can run a query and you're going to get similar to human behavior, where you run it once, you get something, you run it, another time, you might get something different, right? That's kind of an interesting way these systems are behaving. So we are maybe getting closer to AGI in that sense.
Yeah, I mean, it's also like very similar for us. Like when we evaluate um, if it's beautiful or not, right? We don't actually have a standard, right? We are not a machine that try to give a score uh, for someone, right? But we actually try to find the similarities, right? If we find a very like beautiful young lady, then if the other one like looks very similar to this guy, then we think, oh, hey, she's like also very beautiful, right? So for us to understand the whole word, similarity is actually more important than a keyword or a tag or a score, and that makes vector database very different.
Right. Yeah, it all depends on how you define the metric, right? Go into a mathematical endpoint, right? You once you define what your metric is, then you can only find out what the distance function may be, right? So, what motivated you to sort of, you know work on the current, technology that you're working on? What's your secret sauce in terms of what are you trying to do at Zilliz that's different from maybe any competitors or anybody else in the market?
Yeah, we are actually the first company in the world build this concept vector database. I think before us we also have some vector search libraries and also systems, but we are the guy trying to define this vector database as one of the type of the database. The major difference because all for the founders of those, we are all like database guys. So what we're trying to do is, since you have a lot of unstructured data and like vector embeddings, you definitely need a database or like a managed system help you to retrieve the data and like persistent data efficiently. Yeah, and that's the chance we find. And the other like very different is is when we build a company, we decided to open source our technology because we just want more users can be like can get benefit from our products. So it has to be for us to build a like very successful infra. It has to be open sourced. Yeah, that's why from day one we read the code of Mills, we open sourced it, and we donated it to uh, Linux Foundation, I mean, Alpha AI community. It's because we just want to like AI can be also like benefit to everyone. If you just have status and if you want to like uh, build some very your own applications or help you to improve your efficiencies. AI is not like only for large internet companies. It has to be like for everybody. Yeah, I think that's the main reason we want to build a vector DB and also open source it.
Got it. So you need, you know, I think if that's going to change, then you need, you know, I think we need more and more young people getting into, you know, database technology and really, as you mentioned, you mentioned everybody at Zilliz are, you know, database guys, quote unquote, right? And I think if you look back in the history of, you know, the job, database guys, you know, if you look 20 years ago, that wasn't the sexy place to be, right? It wasn't looked up to, you know, the way web development was or anything like that. And I think that might have changed for good, right? I think right now with the explosion of database technologies, you know, you've got graph databases, you got time series databases like KX, there's some really exciting technologies, right, being developed in databases, you know, embeddings and vector databases being one of them. What, you know, give me a hint for, I guess, give the audience a hint for people in technology that are looking at this field as, I think, an expanding, you know, job base. What makes a good database guy?
First of all, I hopefully like after 10 years, there are like no more database guys. I mean, with larger models, right? You can just decide I want to retrieve the data, and maybe like you can just build some agents, and they can help you to retrieve your data, right? Uh, yeah, but I think for now we how we can retrieving data efficiently is still like very very important. I think for build for one who want to build database, I think the first priority is that hardware simplicity. So you still have to because I know as you just said, there are like a lot of engineers, they try to build applications, they but to build a database, you really need to know hardwares, and you really need to know a lot of details about operating systems, about all your hardware performance. That helps you a lot to trade off, to make the right trade off. Yeah, and I think second thing very 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 important is that you have to uh, join a very good open source community, no matter it's MySQL, it's Postgres, it's MongoDB. Read their code, try to learn from them about all the database concepts. Because I think even for today, I thought the database is uh, they have a lot of different abstractions, they have different a lot of different layers. It helps you to make your code very stable and clean, and that's why we want to put vector search into a vector database. Yeah, and we've seen that with the AI industry, like improvement, we see a lot of new scenarios, which means vector database is not uh, only for nearest neighbor search. It also have a lot of different semantics. Like you can still do filtering on vector DB. You can do join on vector DB, and then with a very good knowledge about database, right? That then although like the implementation of vector on the same operations will be like very different, but if you have all the basic, it helps you a lot to understand all these scenarios.
Got it. So a lot of deep technical experience, and then also breadth of knowledge in terms of all the different, you know, sort of capabilities and insights into particular fields of databases. Um, for, you know, for people in the industry, let's say, you know, executives, you know, and CTOs, people in you know, managing technology, managing large enterprises with technology, what do you think, you know, they should know about vector databases and you know, their applications for their companies? What are vector databases going to be changing for enterprise customers?
That is actually a good question. So I guess every company in the future, right? They should be data driven, right? For traditional like when we talk about data driven, we'll also always talk about structured data, right? For merchant company, like how many products you sell, how many transactions you do, right? But I think in the future with large language models, you have all kind of different unstructured data. You have images, you have videos, you have all the user profile informations, you have all the chat history between customers, right? So those informations you have to inside those data that help you to leverage your business. So that's where vector database can jump in. We can help you to inside of your unstructured data, find useful information with the help of embedding models and larger models. You can it can generate a lot of different interesting analysis, help you to do a lot of like a lot of business choice. Yeah.
Got it. So, and then, I guess as you're mentioning this, it seems like an enterprise, there was a lot of siloed data, right? And siloed data was, a major problem. Um, there's been some inroads into that with, cloud providers, data lakes, and trying to sort of, bring all the data together in order to create analytics and provide visibility into and insights into the data. Will, this may be right, may be wrong. Will vector databases maybe help in that sense, where if you've got a general repository of data with all data types, you might be able to manage it a little better?
Yeah, I mean that is also a very interesting question. So we've seen a lot of customers, right? They have a bunch of images, they have a lot of text data. Maybe they also have some text based on the images, right? It can be generated by some models. It also can be like like mark using hand, right? But no matter what it is, like most of the times that they are more focused on handling those tags or those structured data, right? But actually, the unstructured data, for example, the images actually have more informations, right? With vector database, it cannot only handle like one modality. It can also like cross modalities, right? We see a lot of different use cases. You can use neural language to search an image, or even like you can use neural language to help to modify uh like videos or audios. I mean, that helps you to build a connection between all of your data on different modalities. It definitely helps you on the data settle problem, especially with the help of large language models, right? Like you can just give prompts and let your agent help you to find useful informations. Yeah.
Got it. So maybe we'll get more accessibility in terms of being able to use AI to help developers and non-developers also sort of get access to data in that sense.
Exactly. So what may happen in the future is, just as I said, there are probably no more database guys, and yeah, and it's probably, I think, in the future there are like no more data scientists or data engineers. Uh, we'll see that everybody should become a product manager. You can just define what kind of like product you want to build, and then like large language models will help you to build exactly the product, no matter it's a data query, I mean a data query system, right? Or it's just your business system. Yeah.
Got it.
And yeah, I think everybody should be like, especially for engineers, right? Don't really like focus on your implementations. Think about your business.
Huh. So I get so interesting. So pull it back to sort of more of a big picture question. Um, what's your stance on the call for AI regulation right now?
Interesting question. So I I believe the regulation is actually very important. Of course, it prevent harm and get its development towards beneficial outcomes, right? But to some extent, right, I think everyone's current concerns about AI is probably a little bit overdone. I personally still regard AI as a generative tool, so I define it as a tool. So, in other words, like we should more care about people behind those AIs. but not like only manage the larger models itself, right? We should care about what users trying to build on AIs, and I think that is even more dangerous.
Hmm. What kind of societal challenges do you see us facing, with the advent of AI, either in the, very short term, 5 year, or, even longer, 15-year roadmap? What do you think? What do you think are the big societal changes we're going to face?
Oh, okay. So I think we see a lot of challenges, right? One of the challenges I was worried about is I think people may lose their jobs in a couple of years, because yeah, we definitely see a lot of I mean situations that the larger models can be alternatives to like human beings. Yeah, so I think for us it's kind of like very important to think about uh if we have enough like production powers, not everybody need to be working for a life. What will be the our goal to leave, right? We still need to find a reason, right? We cannot just like play for the whole day. So what will be the overall goal for our life after 20 years? Because we're not gonna to like only work for earning money, so keep us alive, right?
Well, if you say, that there's definitely a possibility, that some people's jobs are going to be impacted. What do you think is the industry or the job? Is it, mostly white collar jobs, or is it blue collar jobs, or what's the job type
Mhm.
that you think is going to be most impacted?
Okay, so I think first of all, like on some of the industries, right? Well, where is like very knowledge uh it's kind of like knowledge based, right? Because with larger models and vector database, right? We can search all the domain specific knowledge in just a couple of seconds, right? For certain kind of industries, like lawyers, like doctors, like if you have enough, if we can build very decent systems, maybe we can just serve ourselves with yeah, that is kind of like one possibilities, and the other possibilities is for some of the industries, right? Is more like we have one skills, but for example, for data scientists, right? So we can write SQLs, we can dealing with all the database processings, but if I don't have any sense about your business, then like larger model can help, can jump in and just help you to access the data. So you have to build your kind of like your mode is how better you understand your business. It's not only about you have a skill, right?
Right. Got it. Interesting. Um, since you've been in this field for, for quite a few years now, and you've been sort of, a lot of people are just learning about AI today and they're getting into it, but you've been in it a long time now. What have you learned from implementing AI, using AI, that is challenging, and that you think you can, give some hints and tips for CTOs out there who might be in their first implementations?
Uh, I think the first step, if I'm trying to build any applications or if I'm trying to build any AI product, the first step is always define your data set, or like how you can verify your correctness. Just as I said that larger models have a lot of different possibilities. It's actually very hard to verification if it's good or not. Even for OpenAI, right? When they try to uh, train their models, there are certain kind of scenarios that their larger models performance is just drawback. So you need to do very good evaluations, and the evaluation should based on how good you understand your business. You have to find the evaluation data set on your use cases, and with these evaluation data sets, then you can do fast iterations and get your something we call is a TPF, which is a technology product match. Because like previously, we always talk about PMF is a product market match, right? But now if you're trying to build AI native products, you have to find technology and your product match. I think that is the first step.
Got it. Are there any particular sort of, implications for insecurity that comes with vector databases? Any improvements or difficulties or challenges or new concept in security that are specifically tied to the nature of vector database?
Exactly, yes. So for vector DB, I think the biggest challenge is vector itself is all about semantic, right? So before I read one paper, right, I always taught my customers that you can convert your original data into vectors, and your data will be pretty safe, because nobody knows what this vector means if they don't get the original model, right? So model is at the very beginning, I thought model is like an encryption of your data, but recently I read a paper, right? So with enough training data set, you can convert the vector into the original data, and the 60-70% of the message will still be readable, which means you will have like security issues or like privacy issues. If I have enough of your data set, then what I can try to convert all the vector embeddings in your vector database uh, into your original data, which may contains a lot of your like personal informations. So what we're trying to research recently is how we can convert embeddings, adding some noise into the embeddings, but still keep it searchable. I mean, that is actually a very interesting scenario we'll be working with.
And then I guess lastly, do you want to, could you give me some insights, as the last question, some insights into maybe, upcoming, developments at Zilliz, or things that you're currently working on that you're excited about?
Yeah, for sure, for sure. So one thing, I as I always like mention, right? So vector database is not only about vector; it's also about databases. So oh, for now, I know that like there are a lot of hype in the vector database industry, right? We see like in the last past 1 years, at least 20 different vector databases comes out, right? So what make Mill's different from the other competitors, or what we do are different, is that we still want vector database to be a database. So which means for a database, it has to be has a very you have to have your query language, you have to have your optimizer, you have to have different operations, just as I said. It could be filtering, could be join, could be group by, could be the other aggregations. And the thing excited me about is for all the vectors, we have all, like almost all these operations on vectors, but it's like it's more like a semantic filterings, right? If we have bunch of images, some of them are from dogs, some of them are from cats, then my search could be, can you find the most similar dogs but not cats in my databases? Yeah, it's pretty much like traditional databases, right? But for vector search, the implementation will be like totally different. Yeah, and that make me excited, because which means vector DB can be a real databases. It can be like fully utilize all the traditional database technologies. Yeah, and the second thing I was very excited about is sparse embeddings. So as we may know, that dense embeddings is actually very good at search semantic informations, but sometimes we'll just search for keywords, right? Keywords still going to be very important. If I want to search for yesterday I watch a movie, I definitely can you search for the name? I definitely don't need any information from the day before yesterday, right? Because I asked for yesterday. But for like vector DBs, right? Since it's semantic, since it's similarity, we still can find some result that it's semantic similarity, but it's not accurate, right? So with sparse embeddings, we can search for very exact keyword match, and which can help us to improve the search quality under a lot of different scenarios, especially on retrieval augmented generations. So sometimes you just need to find some corpus or find some documents with specific keywords. Yeah, sparse embedding helps you a lot. So we're going to release the new feature that contains hybrid search, so you can search for both sparse embedding and dense embeddings and convert them all together. It greatly helps the search performance.
Got it. Interesting. Great. All right. Well, thank you so much for your time. Let me